So today we're going to continue in Chapter 1, and we are starting on page 5 in notes. We are continuing in our chapter with equations and inequalities. Today's lesson is 3, and we're going to start solving one-step equations today. This is the very basics to your start of your pre-algebra skills. All right, section A says, what is the algebraic process for solving a one-step equation? And I'm going to make emphasis on this word right here, the algebraic process. All right, step 1 is just to locate the variable. Is the variable an x, a y, a z? Locate the variable. Step 2, undo the operation that is given. And we'll explain that word undo the further we get in notes today. Undo the operation that is given. Now, to undo an operation, it's kind of like you're doing the opposite of that operation. So to undo addition, you would subtract because those two are opposites. To undo subtraction, you would add. Those two operations are opposite operations. To undo multiplication, you would divide. And to undo division, you would multiply. When we solve algebraic equations, we're going to use opposite operations to solve it. Now, there's one that's a little bit trickier than all the others, and you're going to see this in tonight's homework. So to undo multiplying by a fraction, and notice I have highlighted this because I feel that this is going to be the hardest one for you. To undo multiplying by a fraction, you multiply by, hope you can read that, you multiply by its reciprocal. And we're going to talk about that word reciprocal as well during the notes today. And then finally, step 4, remember, what you do to one side of the equal sign, you must do to the other. To keep the equation balanced, you have to use the same operation on both sides to keep it balanced. And again, once you start seeing the examples in Part B, those 4 steps will start to make sense. All right, Part B, can I algebraically solve these equations? Can I algebraically solve these equations? We're going to start you off with a very basic. Example number 1 reads, and I'm going to rewrite it down here for you guys. This should be in your notes though. Example 1 says x plus 12 equals 7. All right, step 1 in your notes said to identify the variable. Here it is. Step 2 in your notes said to undo whatever the operation is. So how do you undo adding? You subtract. So if the equation adds 12, we're going to subtract 12. Not just from one side, but from both. So if I subtract 12 on this side, I have to subtract 12 on that side. So my two inverses, the plus 12 and the minus 12, are going to cancel. And this starts the algebraic process. You drop down x, drop down equals, and then now we've got just 7 minus 12. Now, can you take 12 away from 7? No, exactly. So if I have to do 7 minus 12, I'm probably going to have to KCO that. So those integers are coming back into this lesson. So now I've got x equals, I'm going to KCO it, 7, change subtraction to addition. The opposite of positive 12 is negative 12. And now to finally get my final solution, to add a positive and a negative, you subtract and keep the bigger sign. So I know 7 from 12 is 5, and there are more negatives, so I'm going to keep my answer as negative 5. And it's this algebraic process that I'm going to be checking on. So make sure you are not solving these problems in your head. Show that process. All right, example 2. Over here we've got, I'm going to rewrite it again, 4 equals W minus 6.3. So step 1 says to identify the variable. The variable is W. And right now, the operation that is being used is subtraction. So the opposite of subtracting 6.3, the inverse of subtraction is to add, and I'm going to add 6.3. Now what I do to this side, I have to bounce all the way back over here and do to this side. So now I've got 4 plus 6.3. The minus 6.3 and the plus 6.3 are going to cancel, leaving me with W equals. Now over here you've got to add 4 plus 6.3. Be careful, there is a decimal, so just as a reminder, I'm going to show you how to add those decimals. For my whole number 4, I'm going to write 4.0, then plus 6.3. If I add correctly, I'm going to get 3 decimal points straight down. 4 plus 6 is 10. So W is equal to 10.3. All right, and again, the algebraic process is shown right here. All right, example number 3. All right, so now comes the fractions. All right, so we don't like them, but we can do them. And the process doesn't change. Even though you have fractions, this process is going to remain the same. So let me recopy the question. Step 1, find the variable. It's R. And then look at the operation. They're adding 1/6. So the opposite of adding 1/6, the opposite of adding is to subtract. So I'm going to subtract 1/6 here, and I'm going to subtract 1/6 there, keeping that equation balanced. The plus 1/6 and the minus 1/6, well, those operations are inverses, so they cancel out. So now we can drop down R, we can drop down equals, and then you guys can do this in your head with me. 5/6 minus 1/6 better give us 4/6. Now, are we sure that that answer is complete? Can we still simplify 4/6? Sure we can. Let's divide by 2's on both. So R now is equal to 4 divided by 2 is 2. 6 divided by 2 is 3. So we should get, for example, 3. R is equal to 2/3. Okay, notice the algebraic process. We show the opposite operation by undoing it. We do that to both sides of the equation, and then we can carry down our variable and have it isolated. All right, example 4. Negative 7x, and again I'm rewriting it, equals negative 35. All right, with this particular example, notice there's nothing between the x and the 7. Don't forget there's a hidden multiplication sign there. So my variable is x, and they're multiplying by negative 7. What operation undoes multiplication? Correct, division. So I'm going to, both sides, if they multiply by negative 7, I'm dividing by negative 7. I want those two to cancel out. So the inverse operation of multiplication and division cancel each other out. We can drop down x, we can drop down equals, and a negative divided by a negative is a positive. So we should get x equals, hopefully 35 divided by 7 should make 5. Okay, notice the algebraic process looks a little bit different, but our inverse operations are still there. All right, example, I think we're on example 5. We've got quite a few of these to go. So carefully copy down example number 5. Number 5 reads negative 6 equals W over 8. Negative 6 equals W over 8. Okay, now notice I just recopied it. All right, so step 1, identify the variable, and that's W. Now they're dividing W by 8. So how do we undo division? We multiply. And what we do to one side, we're going to do to the other. So if this is showing division of 8, we're going to multiply by 8 on both sides. The inverses will cancel. The divide 8 and the times 8 cancel, leaving us with W equals, and we've got a positive times a negative. A positive times a negative is a negative, and 8 times 6 is 48. Notice the algebraic process. Show the inverses canceling out. All right, we're down to 3 more examples. Can we do it? Oh, number 6, more fractions. All right, so question 6, I'm just going to recopy it down here. 3/4 times m is equal to 12. All right, so pay close attention to this one. Typically, you undo multiplying by dividing, but this particular problem is showing multiplication of a fraction. So I wanted to point out something that we highlighted back up here. Look close. To undo multiplying by a fraction, multiply by its reciprocal. So that brings me back to a reciprocal. And you haven't seen that term since last year. But I'm going to undo multiplying by 3/4 by multiplying by its reciprocal. The reciprocal of 3/4 is 4/3. So if I multiply this side by 4/3, I have to come over here and multiply this side by 4/3. We have not done fractions in a while, so watch what happens on this. The 4's cancel and the 3's cancel. Nice. That leaves us with the variable m. But now we've got to go back and multiply these two. So remember, I'm going to give my whole number 12 a denominator of 1. And then we can multiply 1 or 2 ways. I think I'm going to do it the easiest way for you guys. I'm just going to tell you to multiply straight across. 12 times 4 is 48. 1 times 3 is 3. So now my answer is 48/3, but it is improper. And remember, we cannot leave an answer improper. So because it's improper, I'm going to divide my 3 into my 48. You guys make sure I'm not making a careless mistake as I divide. 3 goes into 18 6 times. Is my division accurate? So 48/3 is improper. I divide it out to get an answer of 16. This might be an example that you have to go back and rewatch a few times before multiplying by the reciprocal makes perfect sense for you. All right, 2 examples left. Number 7, we're going to practice that reciprocal thing again. Number 7, we've got -2 equals 6/7 p. Again, the invisible multiplication sign is going to go in between. And the opposite of multiplying by a fraction, remember your notes, we highlighted it in yellow. To undo multiplying by a fraction, you're going to multiply by the reciprocal. The reciprocal of 6/7, just flip it. It's 7/6. Then I'm going to jump over here and do the same thing. I'm going to multiply by 7/6. Now the nice thing about multiplying by the reciprocal, the 6's cancel and the 7's cancel, leaving you with the variable p. I'm going to give my whole number, -2, a denominator of 1. And then to make multiplying fractions easy, we're just going to multiply straight across. 7 times -2 is -14. 6 times 1 is 6. And as we look at that answer, we notice that it is improper. So that means I need to divide the denominator into the numerator. 6 goes into 14 twice, which is 12, with 2 left over. So my answer is 2 with a remainder of 2, and my denominator stays the same. The only thing I have to be aware of, see that negative sign? Drop it down. Now, I wish I was done with this answer. However, can you see the fraction 2/6? It can still simplify, so let's knock that fraction down a little bit. I think we can divide them by 2's. 2 divided by 2 is 1. 6 divided by 2 is 3. My whole number, I'm just going to carry it over. So -2 1/3 is the value for p. Please, please, please go back and rewatch this video so that you can see and start to begin understanding the algebraic process.